in chemistry, we will be using very small and very large numbers. For example, at the top here, we have 12 grams of carbon. That's actually a mole of carbon atoms. So a mole is a unit that we commonly use in chemistry, and it describes 6.022 times 10 to the 23rd whatever. In this case, it's atoms of carbon. So we can think of this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This number. It's a very large number, and it's actually a very, very small area. To kind of put this into perspective, when we look at the universe, the current thought is that there is 1 billion trillion stars. So to put that as a number, that's 1 times 10 to the 21. So in a mole of carbon atoms, there are more atoms than there are stars in the universe, at least from what we know right now. Conversely, we could use very, very small numbers. If we look at one carbon atom, one carbon atom has a radius of 70 picometers. This is, in meters, 7.0 times 10 to the negative 11 meters. Each picometer being 10 to the negative 12 meters. Gotta put this into perspective. If we took a carbon atom and scaled it up so that it was the size of an orange, an orange, in our perspective, would then become the size of the Earth. The reason we are bringing up that we use very large numbers or very small numbers in chemistry is if you look back at the mole, that's a lot of zeros to write, and it's easy to lose track. So we use scientific notation. Scientific notation has this format where we have a number in between 1 to 9, followed by all of its digits that are significant, and then a 10 power, which indicates which way the decimal is moving. When this number n is a positive number, we could think of this as larger numbers. In other words, we are moving the decimal to the left. So if I have 100, this written out as scientific notation is 1.00 times 10 to the 2. Notice that in order to get to this number here, I had to take my decimal point and I had to pull it over 2 different places. Conversely, if it's small, 0.01, this is still 1.0 times 10, but this time it's to the negative 2. In order to get to this value, I would need to go 1, 2 to the right. When we see negative powers, we can think of small numbers, and when we see of positive powers, we can think of large numbers. So when we look at the distance from the Earth to the Moon, this is a large number. When I want to put this into scientific notation, I would put 2.389 times 10, and then we can count the spots. So I'm here, and I go 1, 2, 3, 4, 5 miles. Notice I left the zeros off. In the next part of the math module, we'll be going over what are called significant digits. Now, when I look at a dust particle, it has a very low mass. So I would put in all my significant digits times 10, and then I count the number of places I'd move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because it's a very small number, it's negative 10. Notice I went to the right this time, so I have a negative power. And this would have kilograms as a unit.